Ever pondered why your email inbox is remarkably good at distinguishing spam from your important emails? Or how your favorite streaming platform seems to know whether you'll enjoy a movie or not? At the heart of these capabilities is the concept of binary classification, a fundamental task in machine learning. One of the most popular and straightforward methods to tackle binary classification is logistic regression. Imagine wanting to predict if an email is spam or not. This is a classic case of binary classification. The email is either spam, denoted as 1, or it's not, denoted as 0. Logistic regression shines in scenarios like these. To understand logistic regression, think of it as a two-step process. First, a linear combination of the input features is created, and then this combination is fed into the logistic function, which is also known as the sigmoid function. The logistic function, also known as the sigmoid function, is a mathematical function that maps any real-valued number to a value between 0 and 1. It is commonly used in logistic regression to model the relationship between the input variables and the probability of a certain outcome. The logistic function is defined as fx equals sine 1 plus ex, where e is the base of the natural logarithm. The sigmoid shape of the logistic function allows it to smoothly transition from 0 to 1 as the input variable changes. This makes it suitable for modeling probabilities, as probabilities also range from 0 to 1. In the context of logistic regression, the logistic function is used to predict the probability that a given input belongs to a certain class. For example, in the case of spam email classification, the logistic function can be used to predict the probability that an email is spam based on its features. To make predictions using logistic regression, we first calculate the linear combination of the input variables and their corresponding coefficients. This linear combination is then passed through the logistic function to obtain the predicted probability. The logistic function is a key component of logistic regression and is widely used in various fields, including machine learning, statistics, and economics. Its ability to model probabilities and its S-shaped curve make it a powerful tool for classification tasks. But how exactly does this linear combination come about? It's calculated as the sum of each feature multiplied by its corresponding weight, plus a bias term. These weights and the bias term are the coefficients of the logistic regression model, and they're what the training process aims to optimize. The training of a logistic regression model involves a method known as maximum likelihood estimation. The goal here is to find the coefficients that maximize the likelihood of the observed data given the model. But how do we measure if the model is doing a good job? Enter the cost function. In logistic regression, the cost function often used is the log loss or cross-entropy loss. The aim during training is to minimize this cost, which measures the error between the predicted probabilities and the actual labels. Once the model is trained, interpreting it is relatively straightforward. The coefficients tell us how each feature influences the odds of the positive class. A positive coefficient means the feature increases the odds, while a negative coefficient means it decreases the odds. To make a prediction, the logistic function's output for the given input features is calculated. Then this output is compared to a decision threshold, typically set at 0.5. If the output is above this threshold, the model predicts class 1, and if it's below, it predicts class 0. This threshold is known as the decision boundary. In summary, logistic regression is a powerful yet simple tool for binary classification tasks. It's the workhorse behind some of the routine decisions that add convenience to our lives, from filtering spam emails to recommending movies. And the beauty of it lies in its simplicity and interpretability. So the next time you marvel at a binary decision made by a machine, remember there might be a logistic regression model working its magic behind the scenes.